those who are listening to me, now, first of all, is that a telephone that's out? Is that a telephone? Calculator, good. All right. I don't like to use the word FOIL because if you get two trinomials, you don't know what to do. So, Mustafa, I actually don't want you working with your desk partner because it's going to be distracting. So if you think you can do it on your own, do it on your own. But if not, then do this question with me. Okay. So the idea of FOIL is that everything in the first bracket has to multiply everything in the second bracket, right? So in this case, we are going to do FOIL, but I'm just not going to think about first, outside, inside, last. I'm going to do it like this. All right, we're going to start with root 3, and it has to multiply this one. Okay, so when I am multiplying radicals, okay, if I have x times a times, oh no, that doesn't make sense. If I have 2 root 3 times 4 root 5, the coefficient multiplies the coefficient. So 2 times 4, that's 8. And then the radicand multiplies the radicand. So 3 times 5 is 15. Questions about that? That's like a fundamental piece for this question. We good? Okay, so if you have that, the coefficient multiplies the coefficient, radicand multiplies radicand. If you've got that, we can do this. All right, so let's look at the first step of this multiplication. We're going root 3 times 2 root 3. Now, I want to put the 2 first. Now, I'm not going to say root 3 times, I'm not going to write that down. What's 3 times 3? 9. Now, this step you could skip because root 3 times root 3 is just 3, right? So you don't have to write this down. I will, just so it's recorded. Next, root 3 has to multiply the second term. So again, I'm going to put the coefficient first, the negative 4. And then I multiply the 2 radicands. 3 times 5, well, that's 15. Good so far? Okay. Now we're moving on to the second component, the second term in the binomial. It's positive root 5. So root 5 times 2 root 3. Okay, there's only one coefficient, and it's positive times positive. So I have plus 2. What do I get in the radicand? And then this second term has to multiply the other one, right? So everything multiplies everything kind of thing. So I get minus 4 because there's only one coefficient. And then I have 5 times 5, that's 25. Or some of you may just say, well, I know that root 5 times root 5 is 5. So you may have gotten to this point where we're going to simplify. So root 9 is just 3. Notice that the radical sign goes away. Okay, I cannot simplify 15. How do I know that? Well, I've just written down all the perfect squares. So let's write them down, folks. Again and again, let's practice them. What are all the perfect squares? 1, 4, I just write it like this, 9, 16. So all these numbers have a perfect square. What's next? After that, 36. After that, so look, it's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, It's 186?
196.
What is it?
196.
That was 14. What's 15 squared?
225.
I'm pretty sure. I think we're good, right? I think we're good. Okay, but we're looking, we memorize these because we look at 15 and it say, are any of those factors perfect squares? And are they? No, it's 5 and 3, not on this list. 1 and 15, not on this list. I mean, 1 is, but there's no point in dividing anything by 1. So we leave it as root 15. And then the 2 root 15, we could have added them by now, right? Okay, and then the last term, root 25, is just 4 times what? 5. Good. Okay. So I'm going to, 2 times 3 is 6. 4 times 5 is 20. Let's just write the final form. I've got 6 minus 20 is negative 14. And then negative 4. And watch here. The root 15 doesn't change. We're not going 15 minus 15. But we are subtracting the coefficient. Negative 4 plus 2 is negative 2 root 15. Yes?
Does it matter how we write it? Would you rather us put the root first or second?
As far as I know, I don't know if there's an order. So no. And yeah. So the answer is no, I don't care about any order. Okay? We good? Okay. Can we move on to the next one? Okay. Do you want to practice one? Why don't we choose one homework question? Did I not do a 10? I did attendance. I thought I did. Okay. Which one are we doing? Hi, good morning. Hey.
4-2.
Yes, who's 4-2? Yeah, for sure.
No.
Bye.
C, 4A.
Which question are we doing?
4B.
4B?
No, 4C, sorry.
No. We can't do 4C. We are doing, we're going to do 5H. Is that good?
Yeah.
Or no, let's do 5I. Okay? So we're all going to practice this one. 4 root 7 minus 3 root 2. Four root 7 minus 3. Was it root 2?
Yeah.
Okay, and then what?
2 root 7 plus 5 root 2.
Thank you. All right, so we're all practicing 5. Right? Okay, so we're going to go that times We're practicing 5I. You can just see what we're doing here. And maybe you just want to follow and see if you understand what I'm doing here. Just to catch on. So pretty. Yeah? Now, you may have done more steps than me, and you might have done fewer, and that's A-okay. All right, how many people are good with this? Who needs another minute? Can we move on? Or do you guys need another minute? Yeah. All right, folks, let's move on. So this is how we multiply radicals, okay? So basically, the first half of this lesson was about how to do operations with radicals, and we see that it's similar to operations with polynomials. Now we're going to do something called rationalizing the denominator. Now, you know how math teachers are really picky about math grammar? They're like, you need to have an equal sign in every line. Or they'll say, when you have a polynomial, make sure the highest exponent goes first. Or you can never have a decimal in a fraction. Well, Elian, I'm going to teach you another math grammar piece, and that is that you cannot have a radical in the denominator. It's a big no-no. So writing 1 root 2 is just, oh, grossness, say math teachers. Don't do that. So the question is, how do I get rid of having a radical in a denominator? And the answer is da 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 da, rationalizing the denominator. And you are going to be pros at this. Okay. And so when I say simplify, it means make sure there are no radicals in the denominator. Okay. So the reason being, I need to explain why. Anyone know what the square root of root 2 is? No one? Take out your calculator. Who can tell me out loud? 1 point, is it 1.4? For what? Give me more numbers, Polly. Oh. 1.414. Watch this. Root 2 is an irrational number, like pi, 3.14159265535, right? And it keeps going on forever and ever and ever. Well, root 2 is an irrational number as well. So you know how we say, okay, if you have a decimal in the denominator, just multiply it by how many decimals you have, by like tens. Well, you can't do that with an irrational number. You can't multiply it by 1,000 because there's still going to be decimals forever and ever. So you cannot have an irrational number in a denominator. And so let me teach you how to rationalize the denominator, how to make it rational versus irrational. So consider 1 over 3 root 2. Now, we know it's irrational because you have that root 2. Okay? So how can I get rid? Okay, great. How can I get rid of the root 2? And actually, I want to make it even easier. If I have 1 over root 2, okay, what can I multiply the top, the numerator and denominator by to get rid of the radical sign?
Square root 2.
Okay. So is that what you were going to say, Liam?
Yes, I was.
Okay. Do this. Well, 1 times root 2 is just root 2. Root 2 times root 2 is just 2. Now, do you think it's okay to have an irrational number in the numerator? Yes, it's very okay. Okay. It's just not okay to have an irrational number in the denominator. Okay. And so what we did is we have moved the radical sign from the denominator to the numerator. Okay. So how can I do that with 1 over 3 root 2? Okay. What do I need to multiply the denominator by to get rid of the root 2? Julian, what do you think?
Sorry, what?
Want to call a friend? What do I multiply this denominator by?
Oh, you must have talked about it.
Yeah. So what happens if I just multiply this entire fraction by root 2 root 2? So 1 times root 2 is still root 2. 3 root 2 times just root 2. If it helps, you put a 1 in front as the coefficient. Oh, it's just going to be 3. Now it's up to you. Are you going to say root 4? Or are you going to jump straight to saying, well, I know that root 4 is just 2, right? I usually skip this step. I skip this step, but you can keep it if that helps. And so I get root 2 over 6. And that is a simplified form of this fraction. Okay, this is how I have rationalized the denominator. Now, the denominator is a rational number, meaning there are no endless decimals. Okay? So how to rationalize a denominator with a monomial radical? So if I have 1 over root x, okay, we are going to multiply the numerator and denominator by root x, and we end up with root x over x. Okay, if this kind of algebraic formulas and stuff is confusing for you, you can ignore them, right? If it's easier for you to see just how the numbers work, right? So if I wanted to say 1 over root 7, how do I rationalize that? Well, I multiply everything by root 7, and I get root 7 over 7. So you can see that the rational just moves to the top and is multiplied by whatever was in the numerator. We good? Can we go a step further? Yes, we can. All right, conjugate binomials. What? Why do we always have new words? We do. Okay, so conjugate binomial goes on your list of terminology. Who has a list of terminology on the back of their book? Anyone? Okay, start today. Somewhere, have a list of all the terms. Conjugate binomial definitely goes on that list. What is a conjugate binomial? Okay, read this sentence to yourself. These are conjugate binomials. Let's see if you understand. If I have 3 root 2 minus 4 root 7, write the conjugate binomial of this pink one. Okay, that's a binomial, 2 terms. Write the conjugate. So I write the identical binomial, 3 root 2, 4 root 7, But what do I write in the middle here? A plus. So this makes them conjugate binomials. And this reminds me of difference of squares and sum and difference of squares. Okay, so what happened? Did you say you're so lost? Okay, tell me.
How have you found a root two to the fourth root?
I made this up. So this does not equal that. So this is one set of conjugate binomials. Yeah. This is another set of conjugate binomials. I really appreciate you saying that. Say it louder next time. Okay, because I that is confusing. So I just made up a binomial and had you make the conjugate. So what happens when two conjugates are multiplied with each other? Any guesses? Yeah.
I think it's like a squared minus c squared.
Yeah, remember the flow rule that I just love? I wonder if it's going to be like the flow rule. Well, let's see. Okay, so let's multiply these two binomials. Okay, so I get 2 root 7 times 2 root 7. Well, that's 4. Now, folks, instead of saying root 49, I'm just going to say root 7 times root 7 is 7. 2 root 7 times negative 3 root 5. Okay, so 2 times negative 3 is minus 6. 7 times 5 is 35. Now I do the inside, as you like to say. 3 times 2 is 6. 5 times 7 is 35. And the last one. 3 times negative 3 is negative 9. And then instead of saying root 5 times root 5 is root 25, what can I just say? It's just 5. Which two colors can I cross out? I would call that orange. Yes, the purple and red or orange. Because watch, we have negative 6 root 35, positive 6 root 35. So folks, this is like multiplying the sum and difference, right, of two binomials. We've done this before. This is the flow rule. Multiply the first ones and the last ones. So the only ones we had to do is the first two terms and the last two terms. And that, watch here, 4 times 7 is 28. 9 times 5 is minus 45. Ooh la la. Negative 13. Wow. By multiplying two conjugate binomials, I fully, sorry about that. If you can't see, Miles, you just let me know. Maybe it is. Oh, yeah. You tell me. I'm sorry. I know I make mistakes, and I hate that you have to sometimes like wonder if I've made a mistake. But yeah, if you think I made a mistake, I probably did. Negative 17. Watch. By multiplying two conjugate binomials, we are able to fully rationalize those terms. Okay? So let's make a conclusion. Okay. Multiplying two conjugate binomials. Multiply two first terms. Multiply two last terms. And the middle terms cancel out. And this is similar to the flow rule. Fancy math term. So what do you think we're going to do with that? We're not going to just stop at multiplying two conjugates. We're going to do something that is, I guess this would be the most challenging step, but we're doing it step by step. Now what we're going to do is we're going to rationalize a denominator that is a binomial, right? So what we did on the last page is we rationalized a denominator that was a monomial, so one term. Well, now we're going to use those two skills to rationalize a denominator that is a binomial. I want to rewrite this to make it a little bigger. 2 root 7 plus root 5. Who said that? Was that you, Marley?
Yeah.
Does it feel like looking at this question, do you feel like you're at the top of a roller coaster hill and you're like, oh my God, I really don't want to do this? It's painful, right? It's painful. All right. So can we rationalize this denominator? Absolutely. We will rationalize it. Okay. Let's write it down. Rationalize denominator, meaning get rid of the radical signs. Rationalize denominator. And in brackets, I'm going to say get rid of square roots. You don't have to write this down if you don't want to, but sometimes words are helpful. By multiplying numerator and denominator. I'll just write num and den. Denominator. By what's that fancy new word? Yeah, isn't that like so fun? Like I want to get a tattoo of conjugate binomial. And the important thing is it the conjugate binomial of the denominator or of the numerator? Of denominator. Yes, Zach. Yes. So it's really important. If I want the denominator to be rationalized, if I want to get rid of all those square roots in the denominator, I multiply numerator and denominator by the conjugate of the denominator. So let's first write down what is that conjugate. Okay, so I'm going to multiply this fraction, numerator and denominator, by the exact same expression. Who wants to give it a shot? You want to try it, Mustafa?
Yeah.
Okay.
3 square root 7 plus 2 square root 5.
Yeah. 3 root 7 and 2 root 5. Astrid, do you agree? Okay. Miles, do you agree? Okay. What else must I do? What is it, Miles? That's right. And so if the numerator and denominator of this orange fraction is identical, it's as if we're just multiplying a fraction by 1. So now is the painful part. Agreed? It's going to be kind of ugly because we've got... Now I'm going to also add brackets. Now, at least when we are working on the denominator, I can do a shortcut, i.e. the flow rule, the first and last. Okay, so let's start with the denominator. So in the denominator, I know it's first and first. So 3 times root 7 times itself. So what's 3 times 3? 9. Root 7 times root 7? Just 7. Now, if it's the flow rule, will I have a positive or negative? It's going to be a negative. Okay. And now last times last. 2 root 5 times 2 root 5. So 2 times 2 is 4. Root 5 times root 5 is 5. Yes.
So you're only just going plus one for each one.
For a conjugate binomial because it's the flow rule. Okay, because this binomial and this binomial are identical except for the sign in the middle, I can do the shortcut. Okay, but watch. Now let's do the numerator. It's going to be a giant mess. Okay, Sebastian, can you take me through these two terms? So can I take you through it? First, multiply the coefficients. Okay, now multiply the two radicands. Yes. Now, if I have root 7 times root 7, since they're identical, I can just write 7. Okay? So instead of the root, I'm just going to write 7. Is that good? Okay, so you did. Angelina, you're next. This times that. Well, but watch, it's 2 times 2. Yeah, so it's going to be plus 4. Yeah, just drop it there. Yeah. But you have to multiply 7 times 5. No, 35. Okay? Polly, your turn. So Angelina, don't ignore. Look, watch what Polly's doing. So now, Polly, you're doing this one. Good. Okay. And who wants to do the last one? Claire? Good. So because we're saying root 5 times root 5, that just becomes a 5. So it's actually not that painful. All right. Astrid, 6 times 7. Nice. You have decent multiplication tables, right? Yeah. How's that? How did that happen? Kumon. I was gonna no. I love Kumon. Saying it officially on YouTube. I love Kumon. Oh, I wanted to do Kumon when I was little. Okay, Lewis. What do I get with these two? Very close. So you do get 7. And watch this. What do you do with the root, Lewis? You don't change it. So it stays 35. Good. You just add the coefficients. Okay. And then 2 times 5 is plus 10. Okay. Who else thinks they're a rock star at multiplication tables? Lila, do you know 9 times 7? Nice. Okay. And 6 to 3 minus 4 times 5 minus 20. All right. This isn't so bad. Okay. 42 times 10, 52, plus 7 root 35 over 63 minus 20 is 43. Can I simplify this? I could potentially, but I check. What are the multiples of 43? Ding, 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 ding. It's a prime number. So it's just 43 and 1, right? There are no multiples of 43. And so, but if I had something like this, if I had like 28 plus 4 root 3 over 6, could I simplify this? yes, I could take out the common factor of 4, 7 plus root 3, 6, and then say, oh, okay, these divide by 2. So I would get 2, 7 plus root 3 over 3, something like that. Okay, so do see if you can reduce fractions. All right, whose brain right now is like, whoa, that was a bit too much? Like, show me with your thumb. Where is your brain is good, your brain is fried. I'm in the middle. Should we go outside for a break? I'm kidding. I've got people writing a test. That's impossible. Okay, so question. Do you want to now, with the next 15 minutes, do you want to work on homework or do you want to look at the exit card? Or we could look at the exit card tomorrow. Okay, so do homework. Anyone want to go to the whiteboards, work on homework? Do that. Okay, you want to work on paper? You want to ask me questions? I'm available.